Hello everyone, I hope you all are doing great. Welcome to the end of term exam questions. This is the part 1 MCQ, that is multiple choice question part. You will be given 4 options and you just have to select the correct answer. In this question, we will use complementary and supplementary theorems to solve angles. We have been told here to find the measure of angle phi. You can see this is the measure of angle phi. But they have also told measure of angle phi is equal to measure of angle 6. And this is 90 degrees. So here, when you look into this line, when you add up all this, this must be 180, isn't it? Supplementary angle theorem is used here. We can easily understand it's not vertical. Vertical angles is opposite angles. Not that. It is supplementary angle theorem, but what's the angle exactly? This is 90 and these both are equal. So if I consider this as x and x, so it's just going to be x plus 90 plus x, that is equal to 180 degrees. You can just put this in the calculator as equation format and get the answer as well. Or you can do it by 2x equals 90 and solve it up. I'll show you in the calculator how you can directly solve it. Here you can put this x as alpha and closing bracket symbol. That'll be x plus 90 plus x equals is alpha and calc 180. You can see there is only one variable unknown. X is the only thing that's unknown. If it's one variable, you can use this unknown variable x. And then if you press equal to, you'll not get the answer. You need to press shift and then you need to press solve. And here we go. And this is not the correct answer. It's a previous stored answer. When you press equal to, this is the correct answer. So that's the value of x. So it's 45 degree and supplementary angle theorem, option B. What about this one? Here they have told us angle 2. We need to find angle 2. And 2 and 4, you can see this angle 2 and 4 are supplementary. And angle 4 is 105 degrees. Okay, this is 105. And this is supplementary. So we need to find angle 2. When we add these two, angle 2 plus angle 4, what must be the total angle? 180. Why? Because it's supplementary angle theorem. So here it should be either this or this. But what is the actual angle? It will be, it's not 90. Why? Because over here they have told 105. That's equal to 180. And this is what we are solving for. I'll just take it as x. So it'll be 180 minus 105. That's going to be 75 degrees is the correct answer. That's supplementary angle theorem, and 75 degrees. Option C is the correct one. Let's look into the other problems here. They have told us to find the measure of angle 3 and measure of angle 1 is given, and this is 90 degree. Now I'll solve them directly. Now over here, please remember they have not told it's supplementary or anything. They have given us ABC, this total opening is 131 degrees. So let me write this out. The total one is 131 degrees. Measure of angle 1 is 23. This is 90. So all you need to do is 23 degrees plus 90 degrees plus the unknown angle C, which we are solving, will be equal to 131. Put this in the calculator, you'll get it. Or 131 minus 90 minus 23 would be the answer. Please try to solve it by yourself and then look into the steps here. That's known. And now that's the angle addition postulate. By substitution, we get the angle. Answer is 18 degrees. That's the measure of angle 3. Here we have, see now looking at this, I feel this is vertical angles. The answer will be, that theorem will be using vertical opposite angle theorem. Now 6 is given, 7 is given. What we need to do is we need to find the xi, we need to find the measure. So first 2x minus 21, sorry for that 2, it's 3x minus 34. You can see these two are a linear pair, so when you add them up they must be 180 degrees, isn't it? So 2x minus 21, that is equal, sorry, plus 3x minus 34 will be equal to 180 degrees. I'm not going to solve this. I'm directly going to show you in the calculator how to find x. All you do is type 2x, that is alpha, x minus 21 plus 3x minus 34 equals to 180 degrees. Shift and solve, and now the answer is 47 degrees. So we know x is 47 degrees. So what is this angle 6? So it'll be 2 times, let's go back to 2 times, we got 47 degrees for x, isn't it? Minus 21. The answer is 73 degrees, and measure of angle 8 is also 73 degrees. Why? Because they're vertically opposite angles. So that's 73, this is 73. What is the other one? That will be 180 minus 73. So here you can see all the angles. Measure of angle 8 is 73 degrees, 6 and 8 are vertical angles. And what about x? X was 47 degrees. From this, we can easily solve 6 and 7. 7 is 107. So here we go. What about these? These are again supplementary angles, isn't it? It's all 180 degrees. So you can see this and this are equal. 5 and 6 are equal. This is 90 degrees. Just put in the calculator, you'll get the answer. Now, I would ask you to solve the remaining problems by yourselves. They are the same concept. You can just pause the videos over here and then look into the answers. Here we have one. We need to find the measure of all the measure angles over here. But they have told us 1 and 4 are equal and 2 is 28 degrees. And then 2 and 3 are complementary. Complementary means they're 90 degrees. So this is 90 degree. We know 1 and 4 is equal. So there are various ways to solve. See, one of the ways would be, this is 90 degrees. We know 1 and 4. It'll be x and x. So we can first find x because the total thing will be 180 degrees. So this is going to be 45 degrees, 1, and this is also 45 degrees. Now we know this is 28. So 90 minus 28 would be the measure of angle 3. 90 minus 28 is 60, 62. So yes, over here 62 and 45. What about these ones? We had done the similar, we had done at the beginning with the choices. Here we have the steps here. Now look into what is given. They have told 2 and 4 and 4 and 5 are supplementary. That means what's remaining then? So this is what's remaining, right? 3. That is what we need to solve. But we know these 2 and 4 are supplementary. So when you add them up, 2 plus 4, that must be 180. And they have told measure of angle 4 is 105. So this 105 is equal to 180 degrees. And then measure of 2 is remaining. Take it to the other side, you solve it up. That'll be that'll be 75 degrees. So angle 2 is 75. And if angle 2 is 75, then when you, this also will be 75 because it'll be 180 minus this. So that's how we can see the steps. And over here, which theorems do we use? We use supplementary theorem, supplementary angle theorem. 9 and 10. Now, this is a linear pair. That means when you add them up, it's going to be 180 degrees, isn't it? When you add them up, it's a straight line. So this plus this will be equal to 180 degrees. You can use your calculator and solve it up. You find the x and then substitute over here, you get the angles. Very simple. And the last problem of this topic is measure of angle 3 and measure of angle 4. How do you solve this? They're vertically opposite angles. So it will be 2x plus 23. That will be equal to 5x negative 112. You can just put this directly in the calculator and solve, or if you want, you can do it manually as well. Let's take leave the 5x over here because that is bigger. The minus 2x just goes, and this number is moved to the other side. It will be 112 plus 23. Minus becomes plus. So over here we have 135. That is equal to 3x. So now you need to divide. It's going to be 50, 45. I believe 45 is equal to x. So once you know the x, substitute back and then you'll get the answer. So this is how we can solve it, and it's from vertical angles theorem. In this video, we will learn about translations in the coordinate plane. Here we have been given the point Q, that is 4, 2, and the translation vector. It will be in the diamond brackets. You can see these pointy brackets. They're called as diamond brackets, and that is the translation vector. So what we do is very, very simple. You just add the translation vector to the given point. Now if you add, what is the translation vector? -2 to 4. That is the x coordinate, and y coordinate is -2 plus of -5. So the newly formed coordinates would be 2 and -7. So this would be the newly formed translated image coordinates. That is Q dash or Q prime. This line over here shows that it's the transformed or rotated or newly formed image. Now here we are doing about translation, so this is denoting the translation. So the answer would be option C. And let's look into the next one. Here they have told the image A under translation is A prime given over here, the coordinates. So what it means is, if you translate this given point, you get this points. And what is find the image of B under the same translation. So you don't know the translation vector, the vector which is given in the diamond brackets, it's not there. But you have to translate this in the same way the A point is translated. So we know A originally was -3 plus some unknown value x was added to it, and then the answer was 6. So this is the translated image. So what is x? Here if you just take -3 to the other side, it will be 6 plus 3, x is 9. So in the translation vector, the x part would be 9. What is y? The same thing we do. It's -5 plus y, that is equal to -1. So y would be equal to, it will be +5 minus 1, it's 4. So here we go. It should be 9, 4, and that's not the options. That's not the correct answer. We need to translate this now. So what happens here? It is 3 plus 9 and -2 plus 4. So what happens is it'll be 12 and we have 2. That is the newly formed image, that is B prime. And here we go. That's option D. That's how we solve this, 12, 2. Same thing here, just add up the first x part with the x part of the translation. So -3 plus 5 would be 2. And here it's 0, 2, 0 will be the answer. What about this? Same way, please try solving these by yourselves. You can pause the video now and go ahead with the other problems as well. Answer would be just adding them up. It will be 2 and -7 here. Here it will be 12 and 1. Because you add 1.5 with 0 minus 0.5, it will be only 1. And the same thing which we had done. First find the translation vector and then add the translation vector to the point B to get B prime, that is 12, 2. In this question, we will learn about rotations in the coordinate plane. Before we begin with rotations, let's see a few of the rules of rotations. If it is a 90-degree rotation, imagine you have been given certain x and y coordinates. They flip to y and x, and then the y part becomes negative. That means the x in the rotated image. So what I mean is, if you have 2 and 5, only 90-degree rotation about the origin over here, 0, 0. This is not 2 and 5, it's somewhere over here. This is the point 2 and 5. If it's rotated along 90 degree, you know it's going to be in the left side. But what's happening is basically you swap this 5 and 2, but this 5 becomes minus. So -5 and 2, it will be rotated out over here when it's 90 degrees. So this is how we can easily find the rotation using these formulas. 180 degree rotation, just change the sign of x and y, and for 270 it is y and x, where the x part of the original image will be the negative. So you can see it's -x. These are the formulas. Please remember them. They are very, very handy. Now we have a problem here. Quadrilateral ABCD has vertices which are given over here. Determine the vertices of the rotated quadrilateral, that is A prime, B prime, C prime, and D prime, after rotation of 90 degree clockwise. Sorry, counterclockwise. This is very important. All our default rotations are always counterclockwise. When we rotate this point, it'll go outside. You know how a protractor is measured from the right to left, it's counterclockwise. Also, the formulas which we've seen just in the previous page is for counterclockwise itself. Now they have told it's about -1 and 2. The rotation is not about the origin. So there's a bit of a problem we need to solve a little bit, and then we need to do a few of the modifications, changes, and then do the rotation. So since it's in choices, you have 4 choices in front of you, right? When it's quadrilateral, don't go to do all the 4 points. It just takes too long. What you can do is see a point in the option which are unique. See, now these two are fine, different, but this and this is same. So I'm not going to choose A prime. I'm not going to rotate it. Let's see the option B. Yes, B is all different. See, all the options are different. So if I do the rotation for this properly, then I'll directly get the correct answer because all the other options have different points. Even over here, you can choose D. Other than A, I'll just choose B here. So I'm just focusing on the point B. First, what do I have to do? It's along this point. So that means this point is arranged somewhere away, not at the center, right? The rotation. So I'll just add 1 and subtract 2. So whatever is the point B, you should do the inverse of the given point. See, this is about which point? We're doing about -1 and 2 over here, right? Now, no, we know the formula is only about the origin. So let me go back to the origin. So if I'm going back, I have to go down by 1, go down by 2, -2, that's y-axis, and +1 to the right. So what I do is over here, B point will become 1, +1, and 3, -2. If you're thinking why, because the rotation formulas which we know is only about the origin. So we'll rotate about the origin and then we'll add this back, we'll get the answer. So first step, choose a point which is unique in all the 4 options. Then do the inverse of the given point. If they have told -1, just add 1. If they have told +2, just subtract 2. And the newly formed point, this is BO, I'll take because it's along the origin now, 2, and it's 1. Now I will do the rotation. Now what is this? 90-degree rotation. So I know from the formula of 90 degrees, the formula would be, it'll be yx, but the y part, the first part will be minus. So here, B prime, but it's along the origin, will be -1 and 2. Why? Because this comes swaps and the first part becomes minus. Okay, it's still not over. Now this is along the origin. I need to get back to this point, right? So let me go from here. Let me go back to the origin point. That means, again, you'll have to subtract 1 and add 2. That is basically this point itself. So B dash would be, that is B prime, -1, -1, and 2 plus 2. If it's minus, you minus, plus is plus, whatever it's given. So B prime here would be -2 and 4. So this is the correct answer. So it should be -2 and 4. Yeah, that's it. Let's check whether we have, yeah, this is the correct answer. No other option has that, no other point. So we can see that option A is the correct. If you do all the other points, you'll get the same answers as the answers. But why I did not do A1 is, if at all, we had got -2 and 4 as the correct answer. There are 2 options, right? You don't know, then you need to choose one more point. So I strategically chose B prime. I know all the options as unique answers for B prime. So whatever I get will be the correct answer. But you need to do this properly. Now here then, you might have been wondering, what if it's given clockwise? See, even if it's given clockwise as this problem, we see how much it is counterclockwise, and we use the counterclockwise degrees. Now what I mean is, before looking into the problem, they have told 270 degrees clockwise. From here, if I start 270 degrees, 90, 180, 270, I'm going to reach over here. How much is it counterclockwise to reach this point? It is 90 degrees counterclockwise. Or all you can do is just do 360 minus the clockwise, that's 270 degrees. That's 90 degrees counterclockwise. This would be clockwise. So I hope this is clear. Just 360 minus 270, that's 90 degree. If you go clockwise by 270 degrees, it's the same as going 90 degrees counterclock. Now then we can easily solve this up. The given coordinates, 4 and -7. What do we have to do over here? We need to do about this particular point. So let's take the opposite signs first. That'll be 4 -5 and -7, -1. And the answer would be -1, -8. Next, we are now rotating along 90 degrees counterclockwise. That would be, the formula is -y, x. So here this 8 becomes +8 and this -1 remains, but they swap their positions. Now the last part would be adding the given point. So it'll be 8 plus 5, -1 plus 1. That's going to be 13, 0. So that must be the rotated point, and you can see it's 13, 0. This is the answer, Q prime, option D. Hope this is clear. So clockwise or counterclockwise, you need to take counterclockwise itself. Generally, look, if they have not mentioned anything, if they have just told rotate it about, you directly take it as counterclockwise. But 180-degree clockwise or counterclockwise is the same points. It doesn't matter. But generally, they'll give you counterclockwise. But make sure you read the question properly. Now let's try this one. Q, Y, X, Y, Z. So you don't need to do all the points. Just see the options. See which is unique among all the 4 options and do that particular point. I'm just going to do the first one here, 0 and 2. So what I do is I change the sign of the given point. That will be 0 minus 2 and 2 plus 3. That's 5. Now they want it along 180 degrees. So I just have to change the signs. No swapping or anything. It'll be 2 and -5. Now add the given point. That is 2 plus 2 is 4 and -5 minus 3 will be -8. So it should be -4, -8. See this whole method, and then you'll get 4, -8. That's the first point only. Similarly, you can do the other points. I would ask you to solve these problems by yourselves over here. Again, it's a triangle, and this is the point. 270 degrees, we had already done this. Just remember the formula for 270 degrees. It is y, -x, the swapping, right? It swaps and the x, the second part becomes negative. So you can see here, the detailed method is also there. And here we go. These are the rotated points. Similarly, 180 degrees is the easiest of all. It's just changing signs. But since they have given you about a particular point, remember, first step, you need to change the sign of this point. That is, it becomes +3 and +6. Next, you need to do the rotation, -x minus y. And then you need to add this up. You need to take the points as it is. Add in the sense, it'll be -3, -6 itself. And there you go, that'll be the rotated points. Quadrilateral also doesn't matter. It's the same thing. Just choose one. Choose the point looking at the option, and then you can easily, do only one point and get the correct answer. So if at all the graph is given, what you can do is, see, this is point A, isn't it? It's 1, 2, -2, x, 1, 2, 3, 4, +4. So write it out and then you can rotate it. So you can see the given one in the question. Otherwise, if the graphs are given, you can even do like this. And then you can match which is the correct graph. See, it's -3 and 1. Yes, this is the graph. -2 and 4. -2 and 4. Yeah, this is the B prime and so on. You can check the points from the graph. You need to do this. And even if there are 4 different graphs, see the graph which is having a unique point and then look for it. Same thing. Question 5 is also again easy one. It's just a real world problem. They have told about a baseball, a pitch is given over here, and where home plate is 3,3, first base is given, second base and the third base are given. But they have asked you, suppose the baseball field is rotated 270 degrees counterclockwise about the second base. What is the point? You need to do it along this point. That is 13, 13. Now, if you're wondering whether it's positive or negative, just see what is the second base, whatever the value is given. If it's plus, minus, minus. Now, let's just, it'll be, very easy if you take the second base. It should be the same point, but I'll choose some other base. Say, I'll choose the first base here. So what happens is initially you need to change the signs. It'll be 13 minus 13 and 3 minus 13. So you'll have 0, minus 10. Now we rotate it along 270 degrees. So it swaps. The first one will be -10, but this will be 0. -0 doesn't make any sense. It's 0 itself. Now we add this back, it'll be 3, 13. So that must be the first base. Let's look into the answers. And you can see it's 3, 13, that's the first base. Similarly, the second base will be same because it's rotated along about itself. Now, if you're thinking why that is happening, see now, this imagine this picture, I'm rotating it. If I'm rotating, this point is rotated, this is rotated, this is rotated, but I'm rotating about this point. So that's going to be static. Everything else is moving around it. That will not change its position. So that's why that'll be always the same. Similarly, you can do the rest of the problems. They're all pretty straightforward. They're nothing, it's given. Everything is given. This is just a point you need to rotate it along 270 degrees. But it's clockwise, so remember it should be taken 90-degree counterclockwise. We have done this problem at the beginning, the second MCQ. And similarly over here as well. Now this is counterclockwise. You need to solve it up. And this is the answers. Before moving ahead, a quick reminder and a humble request. Please do share my channel and my videos with your friends and to whoever that can benefit from it. And I also kindly ask you if you can hit the subscribe button and like my videos, it would mean a lot. In this question, we will learn about rotational symmetries in two-dimensional figures. Here you have a 2D figure and we need to find whether there is rotational symmetry, and if so, how many times, how many degrees does it take? Basically, what they're asking is, imagine this was the center. If you start rotating this, is there any way to get the same shape back again? Now, a better thing would be like imagine like this. Imagine they are all symmetrical petals. If I turn this around, will I get the same shape ever again? Well, will this be in the same position? Let me consider this to be 1, 2, and 3. If I rotate it just so much, I'm not telling how many degrees, but if I bring this up, this petal up, it's going to be over here. This is going to be over here. This will be 3. The 1 will become over here, and 2. And since I told you they are supposed to be equal, they are all exactly the same. My drawings are not accurate, but they are supposed to be exactly the same. So I'm getting the same shape back here, right? Same thing, let me turn it once again. The 2 will come up, over here it'll be 3, and lastly the 1 will be over here. Again, it's the same shape. So every time I do, and then once I do it again, I get the original image. So I can do it once, twice, thrice, 3 times. So in this case, the answer would be 3. Yes, this has rotational symmetry 3. And if you know this 3 times, it's 360 divided by 3. It's 120 degrees. So every 120 degree you rotate these 3 petals, what happens is you get the original shape back to you. So that means if you have a symmetrical shape, how many parts are same? This is 1, 2, 3 here, 3 parts. You rotate it 3, you can do it 3 times, the same shape will be obtained back, and every 120 degree you rotate, it will be the answer. This is option B. What about this one? See, this doesn't have any, because this is try rotating it. This is a unique shape. There's no symmetrical over here. It's not the same or anything. You rotate it anywhere, you're not going to get anything. You rotate it like this, it'll just be a different shape. Only after 360 degrees you're going to get it. That means no rotational symmetry, not within 360 degrees. Same over here, yes, this has 3 same shapes. So yes, it'll be possible. 1, 2, 3, it'll be, over here they have just asked yes or no. Yes, by rotating within less than 360 degrees, you'll get the original shape. That's every 120 degrees here. What about this? This no, we just saw it. And this is 3, yes, at every 120 degrees. What about this one? You can see almost all these points, 1, 2, 3, 4, 5, 6, 7, 8 times. So you will get it back 8 times within 360 degrees. So it'll be 360 divided by 8. 8 4s are 32, 4.5. That's 45 degrees. Yeah. 45 degrees must be the answer here. Yes. So every 45 degrees, you're going to get the original shape back here. And what about this S? Yes, it's 2 times. It's like, see, the up and down is same, right? Now, what happens is, if you rotate it over here, it's going to come like this S. Now, that's So I hope you get it. This is not possible. We need to have the original shape itself. So that will require 180 degrees or 2 times that's possible. So it should be 180 degrees. And this one, no. You cannot, right? Because you turn it, it should require 360 degrees to come back to this original position. So this is the answer. In this question, we will use properties of equilateral triangles. There are also problems involving isosceles triangles in this topic. Here we have to find the value of x. They've not told anything. The topic heading is of equilateral triangles, but they should tell you in the figure in the question. Otherwise, you can't just assume it. Now here you can see they have told all the three lines are equal. That means it's equilateral. Then all the angles must be 60 degrees. Otherwise, it cannot be equal to each other and it cannot be equilateral otherwise. So here 60, 60, 60 makes it 180. That's equilateral triangle. So each side is 60 degrees. Now we have 6x over here. That means 60 degrees is equal to 6x, or 6x is equal to 60 degree. So let's divide both the sides by 6. You will get 60 by 6, that is 10. This is it. This is the answer. That's option C. Now what about the next one? Here we have to solve for the DE, the side length DE, and then DEF. DEF is this angle. They have not told anything else, but the figure is given to us. We need to use distance formula. I'll do it in distance formula and then I'll teach you some other shortcuts as well. Another thing is, you don't have any other information, only this 90 degree. So let me first find the distance D and then I'll tell you what else you can do, So first let's find D, that'll help us. What is the coordinates here? We'll use distance formula to find it. 1, 2, 3, that is 3, comma. What is the height? 1, 2, 3, 4, 5, 6. And what about this? It's on the axis, it's 0. That's the x value. First is x. And next one, it is 6 over here, 7, 8, 9. And what about the formula? Which one to take as x1 and x2? Before that, I'll write the formula here. The square root of x2 plus x1, the whole square. Sorry, x2 minus x1. My bad, this is minus. And then you plus it with y-axis. x2 minus x1, the whole square, plus y2 minus y1, the whole square. This is the formula. Now you can consider this as x1, then this next one will be y1. You can consider this to be also x1, then this should be y1, but I've done x1 already, so I'll take this as x2, y2. You can interchange them. You can make this set x1, x2, y2, this as x1, y1, answer will be the same. So here we just substitute. x2 is 3 minus 0 the whole square plus y2 is 6 minus 9 the whole square. It will be 3 square, 3 square. It is 9, 18, square root 18, but you can just use the calculator and we need the decimal point value itself. So here we go. I'll just put this entire thing. Now it's blocking the view, but anyways, you can see the screen here. It's square root 3 minus, that is 3 minus 0 the whole square plus 6 minus 9 whole square, and the answer is 3 root 2. It's 4.24. And now here we can just tell this is the answer, but sometimes what happens is the same option will be repeated. You will have 2 DE values at least in the exam. So what about this? Now imagine this first option was also 4.24. This is 90 degree. Can another angle have 90 degree? It's not possible. So therefore we can tell DEF is 45 degrees, or looking at the options you can say it should be 45, not 90. But how to exactly find this angle? Now I have found this side. Now let us find the distance here and here. You will find that is also square root 18. You can do it. Why? Because the coordinates are 0 and 3. Isn't it? And now the distance over here is the same. Or there's one more better way. Now since this is like a symmetrical, it's in the center, draw a line here. Draw a straight line and we will do Pythagoras theorem. That is, what is this distance? 1, 2, 3. This is 3. What is this? 1, 2, 3. It's at the point. Easily we can find this hypotenuse. It's the sum of squares of the other two sides. It's 3 squared plus 3 squared. What about this one? 3, and again this is 3. It is 3 squared plus 3 squared. That means these both the sides are same or equal. It's 4.24, 4.24. In such cases, then this is isosceles and this is 6, the total length. It's not same. Whenever there are two legs that is equal, it's called isosceles triangle. So now isosceles triangle have their base angles, the leg angles, also equal. So if this is 90, these two must be 90 and they're equal. It should be 45 and 45 degrees. So therefore, those are the correct answers. So you can easily do it using Pythagoras theorem rather than the distance formula. Whichever you're comfortable, you can select that. Now I'm going to use the Pythagoras theorem over here. So this is the center. So what is this distance? It's 1, 2, 3, 4, 5, 6. I didn't even read the question. I know we are to find all the sides. Okay, it's to find all the sides. Let's do it now. This is 6. And what about this? 1, 2, 3, 4. What will be this? It will be square root of 6 squared plus 4 squared. So that is 36 plus 16. You can just put in the calculator and get the exact value. Or over here, I'm just going to write 52, square root 52. Now, what about this one here? This is same. What about 1, 2, 3, 4? Again, it's the same distance. So we are going to get this is square root 52, square root 52. That's the distance. And this long length is 8. You can just count linear, right? It's a straight line. You can just count them out. This is total 8. That is RT is 8. ST is square root 52. SR is square root 52. This angle is 56. That means this is isosceles triangle. So this also has to be 56. Now you know two angles. We have to just find this. It is 180 degrees will be equal to total angle, right? 56 degrees plus 56 degrees plus x. So take it to the other side. It will be 180 degrees minus 112 degrees. That is x. So here we go. That will be 68 degrees. So that is the angle S. There are different ways to solve it. It's just electronic, no need of writing. You can just use your calculators and solve it directly. So here we go. Square root 52 is about 7.2 units. It's just more than 7 because square root 49 is 7 and it's a little more than that. And what about the angles? It's 68, 56 and 56. We just did this in the MCQ as a multiple choice and you can see here it is square root 18. This is wrong. It should be 3 root 2. Isn't it? Because 9 is 3 root 2. So that is wrong. It is either 3 root 2 or root 18, which was 4.24, I believe. And then we found this was isosceles, so it has to be 45 and 45 degrees. What about this one? This is equilateral. Oh, no, wait a minute. Yes, it is an equilateral. Why? Because this is 60. We don't know these two angles, but they have told this side and this side is equal. So that means that's an isosceles over there, and these must be equal. But we know this is already 60, so it has to be all 60s. Because see, x plus x, and we know 1 is 60. That must be equal to 180 degrees, isn't it? So it'll be 2x plus 60 is equal to 180 degrees. Or you can just take it over there. 2x is equal to 120 because 180 minus 60 is 120. X is 60. Remember, these two angles must be equal. But 1 is 60. That means all are 60 because the equilateral has to have 60. Another thing. Now the sides are equal. Why? Because it's the equilateral. Now how we can find x is 3x plus 8 is equal to 4x minus 4. Now we can solve it up. 8, 4 comes over here, plus 4 equals 4x minus 3x. 12 is equal to x. You can also do these equations directly in the calculator. I'll show you how. All you do is write this variable as x itself. Alpha and closing bracket symbol gives you x plus 8. The equal to is by alpha and calc. That gives you equal to 4x plus minus 4. Sorry, it's shift and solve. Now, wait a minute. If you press equal to, you will not get the answer because you have used the equation equal to. So you need to press shift and then solve this equation. This is not the answer. Press equal to now. This is the correct answer. Okay, this whatever when you press equal to first time, shift equal to, you'll get the previously stored answer. So now this is the correct answer. Now say for example, I'll just change this to plus 2. Shift and solve. This is not the correct answer. When I press equal to now, this is the correct answer. I hope that's clear. And here we go. What about this one? 3, 3. And there is 60. So now here, 3, 3, this has to be 60 and 60, and if it's 60, then all are 60. And that's it. Measure of angle B is 60, and AC is 3 because it's an equilateral triangle. Over here as well, it's the same thing. We have to solve this. This is equal to 60. 6x equals 60 is giving you x is equal to 10. And what about this one? See, this is equal, this is equal. So bases must be equal. We did a similar problem. Now 1 is 60, then this has to be 60 and 60 degrees, and the side length would be 777. Look, this is electronic part. You don't need to do any methods, no need of writing. Just choosing the correct answer, right? Look at this, write it and choose the correct one. Here as well. Now here we know all the angles are equal, then it has to be equilateral because it's only 60-degree possibility. So all of them are equal, so each of them is 60 degrees here, here and here. But they have told this is 3x. So 60 degrees is equal to 3x, or divide both the sides by 3, that will give you 20 is equal to x. So answer is 20. So that's it. What about this one? Again, we know it's an equilateral because all are same, but they're not telling us to find the sides. They're asking x value. So x value is basically 4x equals 40. Why? Because this all sides also are equal in an equilateral triangle. So divide both the sides by 4, x will be equal to 10. That's it. A real world problem. I mean, it seemed like what we just now did. Here they have told some tortilla chips can be modeled by a triangle. Solve for x. So now we have to solve x over here. See what is given to us. They have told this one and this one is equal. That means these two angles must be equal. But look carefully here, this and this angle is equal. So if this and this already is equal, and then you know these both are equal, by transitive property this is also equal. It's all 60s. Because if three sides are equal, it has to be only 60 for each angle, and this is an equilateral. So now if this, then even this is equal because it's equilateral. 6x plus 3 is equal to 27. 6x is equal to 27 goes to the 3 goes to the other side, will be 24. X is equal to 4. That's the answer. And they'll ask you to find the y as well. Just make this equal to each other. That means all the angles are equal. It's 2y. Oh, sorry, don't make it equal to each other. See, now what happens if you make them equal to each other? They're literally the same. They cancel off. It's 0 is equal to 0. It's identity. Now, you need to know what is the angle. You know, 2y plus 4 is equal to 60 degrees. So now we can solve it. 2y is equal to 4 to the other side minus 4. So it will be 56 degrees. And y is equal to 25 and 28. Sorry, this is 28. Y is equal to 28 value. That's how we solve this one. And what about this? Here, say one angle is 60 degrees and they have told these both are equal. So if this is 60, then this has to be 60. If two are 60, then the third one has to be 60 degrees. So let's find for x now. They all sides will be equal because it's equilateral. 4x plus 2 is equal to 3x plus 9. You can directly use calculator to solve as well. Here now 4x minus 3x is equal to 9 minus 2. X is equal to 7. And what about the angles? Angle at 60 degree will be equal to 4y. So divide both the sides by 4. You are going to get 4, 10, 15. 15 is equal to y. That's the answer. So x was 7 and y is 15. In this question, we will draw reflections in the coordinate plane. They have asked us to determine the coordinates of, say, q is given 6, minus 4 after a reflection in the line along x is equal to 2. So you need to find q prime or the newly transformed image. There are 4 options, which is the correct one. The easiest and the simplest method is not any shortcuts, just drawing it out. You know, just let's draw it for our own understanding. 6, where is 6 over here somewhere? Imagine that 6 and minus 4 means somewhere over here. It's not to the scale, but anyway, this is the point, okay? Where is x is equal to 2? Over here, right, somewhere. Let's draw a line. Imagine this is the mirror. Okay, that's a very bad line. But anyways, imagine this is a straight line here. This is like a mirror and this is being reflected along that. Now, if you're standing here and you're seeing over here the mirror, you can see the reflection, but actually it shows you as if you're far away from here, right? How much distance is this from this point to this point? This is 2, that is 4 here. So now that means you need to trace back 4 behind. That means you must go from here to another 2. So it'll be minus 2. So the x value must be minus 2. So you'll be somewhere here, this point reflects from this behind. If the reflection was more than that, it'll be other side. But now this is the point of reflection. See that line, right? At 2, from here to here it's 4, so that'll be 4 behind it. It's that side, and we can count from 2. It'll be 1, 0, minus 1, minus 2. So which is minus 2? These two. But what about the y-axis? It has nothing to do with y-axis. It'll remain on the same point. So it's minus 4 and minus 2, option D. Now the easy way, another thing is, remember when x is equal to 2 or x is equal to 5 or something like that, this x value will change, because this you should see how much is the distance and then change it. Y value does not change at all. But if it was y is equal to 3, say y is equal to 3 over here somewhere, then along the y-axis it will change. This distance goes behind, this changes, but the x-axis value will remain the same in that case. Depends on where they have asked you to reflect it. The reflection line is important. So here it's option D. Now we have banners. Fiona is making a banner in the shape of a triangle for a school project. She graphs the banner on a coordinate plane with vertices given over here, PQR. She wants to reflect the banner over the line x is equal to 1. Find the coordinates after reflection. See, I'm not going to draw a triangle, everything. It's not a writing exam. It's, choices are given. So what happens is, focus on one point at a time. I'll just do P first. And look, P are almost all the options are different. So if I just do one of the point, I'm not going to choose Q. Why? Because there are 2 points same over here. So if at all, if I get this correct answer, 0 and 8, it might be this or this. So I need to choose another point. But I'm just going to choose P because all are unique answers. What is P? 0, 4. So 0 is over here, x-axis. 4. This is the point. Where do you have to reflect this? X is equal to 1. That means somewhere over here. So reflection along x is equal to 1. How much is this? It's 1, right? Because this is 1, this is 0. And this is 0, 4. So 1 over here would be, 1 more over here, that will be x is equal to 2 here. So the reflected point would be 2, how much? 4. Y-axis does not change. So the answer is option C. That's it. You don't even need to do the other things. Now, if at all, okay, that was, there are 2 options. Then what about the next one? 2, 8. Let me do that. 2, x is 2, sorry, over here, and 8 somewhere up over here. So we are reflecting along this point, right? How much is the distance? It's 1. So we'll go over here, it will be 0. So it should be 0, 8 then. Yes, it's 0, 8. What about the last point? Minus 3 somewhere over here, minus 3, this is 0, so minus 3 is over here, and 6 somewhere here. And it's along this line. So now this is gonna, see, you need to count a lot. First, 6 is not gonna change, that is staying same. Minus 3 to 1, how much is the distance? Minus 3 to 1, it'll be minus 3 plus 1, it's 4. 3 plus 1, it's 4. So you need to add 4 to 1, not to minus 3 to 1, because if you add 4 to minus 1, you'll reach 1. That is where it's reflected. So it's going to be 5 here, rightmost. Yes, that's the correct answer. That is how easily, just with a small sketch, a rough graph, you can easily find the reflections. Now determine the coordinates. S is equal to minus 7, 1 after the reflection in the line y is equal to 3. Now we have not done yet any line on the vertical axis. So S is minus 7 and 1. It's somewhere over here. Reflection along 3, that is over here. Y is 3. This is 1. Okay. So it'll go up. Why? Because 1, 2, 3, there's 2 units distance, right? So it'll be over here, it'll be 5. That should be 5. So this will be the point after a reflection along the line y is equal to 3. So it'll be minus 7, 5. That is the answer. So here you can see it'll be minus 7, 5. What about this one? We did this, is it? I think so, yeah. So here, what happens? Only the x value changes. Yes, we did it at the beginning. So it's -2 and -4. Now, we did this just now. Here are the coordinates. And what about this one? Alia is drawing the top view of a square sandbox on a coordinate plane with vertices given over here, D, E, F, G. She wants to change the location of the sandbox so that it is in the shade. She reflects the sandbox in the line x is equal to 1. Find the coordinates of the image of the sandbox. Just like what we have done a while ago. So I'm just going to choose, so I'm going to strategically choose a point. Now here there are many points, but look into the options and choose any one. Even you can do all the points. Now where do you reflect it? It's along x is equal to 1. This is the point where we reflect it. Now let me do this 1 and 1 because, it's on the 1. How do we do it? So here, 1, 1. What happens when you reflect it? It's along that same line. It's on the line. It does not change at all. It will remain over there itself because it's not away. There is no distance to be reflected. It stays the same. Now E is 1 and 6. Imagine this is 1 and 6. Again, it's on this line of reflection, so it's not going to change. But what about 6 and 6? This is 6. Imagine this is 6 and 6. Now, yes, there is a change. Why? Because this distance from the reflection, 1 to 6 is 5. It goes 5 behind, so it should be -4 because 1 minus 5 will be -4. So this will be the point after reflection. And 6 and 1, same thing. It will be -4 and 1. So here -4 and 6. So only these are the two changes. The other two will be the same. Here you can see 1 and 1 does not change. Even 1 and 6 does not change. But other two, -4 and 6 and -4 and 1. That's the answers. Determine the coordinates over here. Okay, after the reflection along the line y is equal to 9. So y is equal to 9. It's somewhere I up above. Imagine that's 9. And we have a point -7 somewhere over here and 4. So what is the distance to 9 from 4? It's 5. So it'll go up by 5. So 9 plus 5 is 13. -7 remains. It'll be -7 and 13. So it'll be somewhere over here. That point will be -7, 13. It's very simple. If you draw it, it's the best way. That's the easiest way. Wait a minute. Did I count it correct? See now, what did I do? I did a mistake. I counted it wrong. 5, right? 9 plus 5 is not 13. It's 14. My bad. Simple calculation. I did 4. 9 plus 5 is 14. So answer is 14. Why? Because the distance from this point to the line of reflection is 5. You need to add 5 to 9. That'll be 14, not 13. That is the answer. -7 remains the same because only the y value changes. Before moving ahead, a quick reminder and a humble request. Please do share my channel and my videos with your friends and to whoever that can benefit from it. And I also kindly ask you if you can hit the subscribe button and like my videos, it would mean a lot. In this question, we'll determine angles formed by the parallel lines and transversals. Here you can see in this figure given, measure of angle 7 is given to us and they have mentioned it to be 100 degrees. So this is 100 degrees. What is the measure of this angle here? 11. This and this, since they are all parallel lines and there's a transversal, they're corresponding angles and corresponding angles are congruent or equal to each other. So it must be 100. So that is C. What about angle 5? Here you can see this is the angle. Now these both 5 and 7 are vertically opposite angle. That means whatever is angle 7 is equal to angle 5. So therefore again it is 100 degrees. That's option C. Or you can also find angle 8. Angle 8 is how much? 180 minus this angle. So it's going to be 80, right? So 180 because it's a straight line. 180 minus 100 is 80. Then again this is a linear pair. So 180 minus 80 would be 100 itself. However you do, you will get the same answer, but very easy to understand. This is vertically opposite angles. Let us solve some more angles here. In the figure, measure of angle 7 is 100 itself. What about 9? How about we'll find all the angles? See over here, this is 100. So it's 100. This is going to be 100. This is going to be 100. Opposites are all again 100. Why? Because if this is 100, the vertically opposite is also 100. This is corresponding angles, vertically opposite. So all these are 100, which I've marked in one line. Now, how do we find measure of angle 8? We know this is a linear pair. 180 minus 100 is 80. So this is 80. That means this will be 80, 80, and then vertically opposite, this is all 80. So let me put two lines here to differentiate. This is all 80s here also, and lastly here. So that is how we can easily determine. So now what is measure of 9? That is 100. 6 is 80. This is 80, so it's vertically opposite 80. What is 8? It's 80. What is 2? 80 again. What is 5? 100. And lastly 11 is also 100. In this question, we will use slope to identify parallel and perpendicular lines. Basically, we are writing the equation. We are finding which is the correct equation for the particular lines. They have asked us to write a line which passes through this point and parallel to this equation. Now remember, if it's parallel, this is parallel short form, and this is perpendicular. You can write LAR. This is perpendicular symbol. This is parallel symbol. LE to write parallel, perpendicular. Now what happens with the slope? If the slope is m, then that is equal to m itself. But here if the slope is m, then it will correspond, the perpendicular slope will be minus 1 by m. What do I mean by this? Say for example, you have a slope of minus 2 by 3 here, because I'm just taking this, that'll be the same thing. But here minus 2 by 3 would have been, swap this up. 1 by m would be inverse, that will be, just swap them up, 3 by 2, and minus would be positive. If it was positive, it would be minus, opposite signs. So this is what will be in perpendicular. Now what we have is parallel, so this is the slope. Now then, how do we solve it? We have these 2 points which must be which the equation must pass by, right? So let's remember the very important, very simple formula, mx plus b, that is y is equal to mx plus b. I'm sure you all remember this. So here, what is y and x? This is x, y. We have to have an equation which passes by this line. So we will consider 2 equals. Now what is m? M is the slope. It's minus 2 by 3. X is 6 plus b. Now let's solve this up. 2 is equal to 3 minus 2 times 2 will be, I'll write it directly, minus 4. That is plus b. You take it to the other side, it'll be 6 is equal to b. So now again the same equation we can write. Y is equal to, what is m? It's 2/3 to minus 2 by 3. X plus b value is 6. So this is the answer, which is it. That's the first one, right? Yeah, that's it. So once you find b, it's done. You can figure out which is the correct answer. As simple as that. That's option A. Well, let's do this one. Here they have told us perpendicular line. So the slope over here would have been for perpendicular line plus 1 by 5. So look into which is having plus 1 by 5. I can easily figure out the correct answer here itself. But what if in the exam there were 2 options with plus 1 by 5? Now then we have to write y is equal to mx plus b. And what are the y and x values? It's 2 is equal to m is 1/5, x is minus 2 plus b. And then solve it up. Here it will be minus 2 by 5th. 2 plus b, and we'll take it to the other side. It will be 2 plus 2/5 equals b. So how you solve it? Just use the calculator. Over here only you can use the calculator and get the answer, this b value. But I'll show you, I mean, if you're doing it in mind, then we have to multiply 5 and 5 here. So it's going to be 10 plus 2, it's 12 by 5. That is equal to b here. Now let me show you in calculator how you can do it directly. So here we have 2 equals it's plus 1 by 5. 1 by 5 times minus 2. Let me use the bracket because there's minus 2. And then we have plus unknown value. That is what we are solving for, right? It's plus x. Shift and solve and then press equal to. The answer is 2.4. What is 2.4 exactly? If you press S and D, SD, that is search to decimals. or decimals to thirds. It's 12 by 5. You can see that's the answer. 12 by 5 is the correct answer. Please do try these problems by yourselves. If you have understood, do them by yourselves, but I'm going to solve them anyways. Now here we have minus 7, minus 4. So here we go. What is it? Perpendicular line. So it'll be minus 2. The slope is minus 2. Y is equal to mx plus b. And all you do is substitute. Minus 4 is equal to minus 2 times minus 7 plus b. It is going to be positive 14. That goes to the other side. It'll be minus 14. So it'll be minus 18 equals b. So this is enough, but the equation, if you want to write it out, will be minus 2x minus 18. So that's the solution. What about over here? It's a similar thing. It's parallel to y is equal to 7. So here, y is equal to 7 is a straight line. See now, is there any mx plus b? No, it's basically a straight line. I mean, not a vertical line. It's a horizontal line like this at 7. So you need to draw a line that is parallel to this. Now we can just, if at all, there is x is equal to something or y is equal to something, rather than solving, and since it's in the electronic part, just let's analyze this. It must pass through minus 1 and minus 10. Where is minus 1? X. And minus 10, it's somewhere over here. Okay. So this is the line. So what must be the line? It has to be parallel. So it is y is equal to minus 10. That's it. So another way to understand is, if at all you have been told y is equal to 7 and it's parallel, so what is this y value here? Minus 10, that would be the answer. It's minus 10. Or you can do even the slope. What is the slope here? There is no mx. So slope is 0. Don't take slope is 7. Slope is 0 and then put it in the calculator. You'll get the answer. I mean, y is equal to mx. But rather than that, just analyze this. Whenever I see y is equal to 7, okay, this is it. If it was x is equal to something and parallel to that, then see what is the x line? That would be the parallel line. That would be the equation. We had solved this problem at the beginning. Over here, it's parallel lines. It's the same slope, so you can easily use the same number, that is minus 2 by 3, and solve it up. The b value is 6, so therefore this is the equation. And the last problem as well, we solved it at the beginning. Here it's perpendicular line. So the slope is 1 by 5, and then you can easily solve it up. In this question, we will use AAS postulate, that's angle side postulate, to prove the triangle congruence. These are all supposed to be proving problems. So let's try and understand how do we prove it, and then we can easily solve, we can get the correct answers. Your flow proof, they have given you a flow proof that is basically, flow charts. You can see a part over here, and then all of it points to what's the reason and why we are proving it. It's given that JK, can you see this line? JK and MK are equal. They have mentioned it. N and L are equal to each other. That means, see this and this angle. We need to prove these two triangles are congruent to each other. So we know for sure they must be congruent. Now, which is the angle that will be, that can help us prove that? Here the objective of this topic, it's AAS postulate. That means it's angle side, isn't it? So we have one side, we have one angle. We need to look for one more angle. When I look here, this is the vertically opposite angle K. Because you can see whenever we have opposite angles like this, they're equal and these two are equal over here. So then we can easily say JKN must be congruent to LKM. Why? Because they're vertically opposite angles, vertical angle theorem. So what is the reason here? It is this option B is the reason actually. That is the reason for the third one, because this is missing, right? So over here they have told what is the reason for JKN being congruent to MKL. That's vertical angle theorem. Let's look at this one. Here they have told MS and RQ. See, they're congruent and they're also parallel. Now, if they are parallel, then we can use a lot of theorems, say alternate opposite angles, vertical opposite angles. There are plenty of it. Let's see, what do we have to solve for? The reason behind MSP, what is MSP? This angle, and RQP. RQP is over here, this angle. Can you see this angle which I've crossed twice? See these angles, how are they equal? They're alternate angles because this is at left and right. So they're alternate and they're inside, right? The inside these two lines. See, they're parallel lines inside them. So it's alternate interior angles. That would be the answer. So it's option A here. What about this one? Let's prove it. So choose the correct statement. So since it's the MCQ part, they will ask you the reason for certain points to be equal, but let us just prove it. I'm not going to prove it in detail, not like writing part. I'll just tell you why and which terms are equal. RQ over here is congruent to ST and they are also parallel to ST. If that is the case, it's very, very simple. This angle will be congruent to this angle. Why? Alternate interior angles. Now this angle is congruent to this angle. Why? Alternate interior. This is vertical. But since you have to use AAS, let's just choose two angles here. I know this line they have already given me is congruent to this line. So then I'll just choose two more angles. I'll choose this and this, this and this. That's fine. So therefore I can tell they're congruent. Now this is given, but now RQS, you can see RQS, this angle here, and TSQ are congruent. Why? Because they're alternate angles. So we have one more angle, RUQ and TUS, they're vertical angles. And here, oh sorry, no, this is this is the triangle. This is the final answer. This had to be the thing. RUQ and TUS. So this and this and this are angle and we have a side. So there are two angles and one side, therefore it is AAS postulate. Here you can see it's alternate interior angles, vertical angles theorem, and it's angle side postulate. How about this problem? It's same way. Here then, let's see what is given first. DAC. So DAC, this is congruent to BEC. BEC, this one. These two angles are done. And then we know that DC, can you see this line DC? Is congruent to BC. Okay. This and this is congruent. Now you can see there are two triangles. Let me draw the triangle here. That is one. Okay, that is a very bad choice of choosing the color. Let me choose this color here. Okay, those are the two triangles. I hope you can differentiate it. One is A, C, and D. One more is E, B, and C. Now, what is one more angle? Because we got one angle and one side. So we need two angles, right? You can see this is literally the same reflexive property. It's the same angle for both. So we can say it's angle C. So we have DAC and BEC, that's given basically. Here another one is also given. What next? Angle C and C, that's reflexive property. And lastly, they are congruent triangles because of AAS postulate. Here we have a two-column proof similar to what we were doing. We'll directly see what's the reason behind the congruency. BC is parallel to EF. That means this is corresponding angle. This is all you can find these are all equal. There are not all, sorry. We don't know whether these both are parallel. So I know for sure this is parallel to this, right? So I can only tell B is corresponding to E, not anything else, okay? And AB, where is AB? This side is congruent to DE. So I know one angle, one side, and they have told us C and F. Here C and F are congruent. Okay, basically they have told everything, right? So what is, okay, now they have just not given any side, right? No, they have told side. My bad, this is not given, guys. This is not given, that B and E is not given. I told you that it is. Why? Because these two lines are parallel, so they will be congruent because they're corresponding angles. That's it. So it's proved. Angle, and side. I hope that's clear. See, BC and EF, that's the given. And over here we know AB and DE are congruent given. C and F is congruent. So therefore, we can easily tell they're, this one, ABC and DEF are equal to each other because of corresponding angles. Therefore, these both triangles are congruent to each other. That is AAS postulate. here as well, even without going through the given, because they have given you the signs, you can just figure it out. Looking at this, I can easily tell this is equal, they have told, and this is also equal. This line RT is reflexive for both. And then we must see, because I can't proceed with this, I need to have one more angle, right? RT bisects STU. If it bisects, then this angle and this angle is equal. So now we have two angles and one side, so it's AAS postulate. That's it. What about this one here? Let's see, JK and MK that is given. They are equal sides. N and L are equal. See, now here they have not told anything about parallelity between any lines. Therefore, you must know this is vertical angles must be equal. So we got two angles, one side. That is the answer. So you can see vertical angles. That is what? Which angle? MKN and MKL or LKM. And here as well, paragraph 2, DE, you can see DE is parallel to FG. These two lines are parallel. Now, if those two lines are parallel, we have a lot of things. This is alternate angles, and this is angle which is given to us, and this is the same side, so it's reflexive side. So we can say it's AAS postulate because there are two angles and the side. What about this one here? Again, it's similar one. We have been told U and U, Y and WX are parallel. If they are parallel, then there are plenty of equal or congruent angles. Then what about the next one? They have told also V is the midpoint of Y and W. So this side is equal to this side. So angle side, angle done. Look here, we are supposed to prove it by angle side, angle side. That means there must be two angles and then one side. So we can take two angles and a side. Here we go. You can just go through this. The most important thing is you should know the reasoning behind why they are congruent. See now, VWX, where is W here? VWX is congruent to VYU. That means they both are alternate. W over here and Y over here are alternate interior angles. That's the reason. So understand the reason, that would be more than enough. Here we have MS is parallel to RQ. That's this line. MS is also congruent, parallel and congruent. They have told both parallel and congruent. That means then you have to find two angles, one of this angle and one of the vertical opposite angles, or you can find two alternate angles itself. It's up to you. So we have vertical angle and alternate angle. So angle, and side congruency. Before moving ahead, a quick reminder and a humble request. Please do share my channel and my videos with your friends and to whoever that can benefit from it. And I also kindly ask you if you can hit the subscribe button and like my videos, it would mean a lot. In this question, we will use the slope to identify whether the lines are parallel or perpendicular. You can see here we need to determine these two lines, that is x is equal to -2 and x is equal to minus a positive 4, whether they are parallel, perpendicular, or neither. Neither means none of them. So imagine you have a slope of 3 and you have a slope of 2 by 3. The slopes are not same, they're not the negative reciprocal, so they're neither. So here what we'll do is first let's analyze this. X and x. What is the slope? The slope is literally the same, but these are lines here like this. -2 is somewhere over here a straight line, 4 is somewhere a straight line. They are vertical lines at x is equal to -2 and x is equal to 4. They are parallel because they don't have y terms, it's only x terms. Whenever you see two x terms, directly you can write they're parallel. But imagine it was x is equal to -2 and y is equal to 4. Then this would mean they are perpendicular. These two lines, they'll be perpendicular to each other in such cases. So here it's parallel, that's the answer. Now determine whether, again the same thing. Let's look into the slopes. See, I'm not going to solve the entire equation. This slope over here is done, -3 by 4. Here, look at the x term. I'm just going to solve this right side because this is just a number. It doesn't have any x, so my x won't change. So -3/4 x plus over here, whatever, it's a number, doesn't matter. Look at the slope here and here, they're same. That is minus 3 by 4 and minus 3 by 4. The m values are same. So they are again parallel here. They are parallel to each other. Now let's look into this problem. What can we do here? It is y is equal to 3x minus 2 and y minus 0 is given. Now I am only interested in the slopes. M is 3 here in the first line. And what about this? Minus 1 by 3. Are they negative reciprocals? Yes, if you multiply both of them, that's 3 times minus 1/3. I'm getting minus 1. Yes, they are perpendicular. They're not same. Of course, they cannot be parallel. But negative reciprocal means if you have 3, it will be 1/3, but then write a minus opposite sign. Say you had plus 2 by 3. Then minus 3 by 2, it says negative reciprocal. If you have minus 4, then positive 1 by 4 is its negative reciprocal. If you have 5, then minus 1 by 5 is its negative reciprocal. These all slopes means they are perpendicular. Here they are perpendicular lines. It's just a multiple choice question, so you can directly write they are perpendicular. And over here now, y and x, I can directly say they must be perpendicular itself. Why? Because if you graph them out, they'll be perpendicular. See here, you can see vertical and horizontal lines are always perpendicular. This is a horizontal line. At y is equal to 3, this is a horizontal line, and x is equal to 1. They'll be always perpendicular to each other. Now then, look at this one. Here I'm just going to look at the slope. It's minus 3/4 x, and over here we did this at the beginning. Yes, they are parallel to each other because of the same slopes. Here we can see they are parallel. That's the answer. What about this line? These are also parallel. We did at the beginning. They are two horizontal lines, sorry, vertical lines. At minus 2 and 4, they're parallel to each other. So here we go. Vertical lines. It's not, these are vertical lines are always parallel. If it was vertical and horizontal, it'll be perpendicular. In this question, we will prove two lines are parallel. Here they have asked us to state the postulates or the theorems that justify our answer. They have told the measure of angle 3 is congruent to phi. You can see 3 and phi here. They're congruent to each other. If they are congruent to each other, these lines are parallel. Yes, of course. Why? Because you need to state the postulate now. We will see which postulate they are. They're opposite to each other. So it has to do something with alternate. Okay, because they are alternate, opposite. And look here, the lines L and M are in question here. It's not N and K. It can't be possible. Why? Because they both fall on N. And which are the two lines they'll make them parallel? It's L and M. So L is parallel to M because of which postulate? Alternate. They both are inside these two lines, so it's interior. The converse of this, interior. So that is the one. We should see alternate interior. But this is the correct answer, not the L parallel to N, because L is not parallel to N at all. It's L and M, and that's alternate interior angles converse. Because if these two lines are parallel to each other, then these both are congruent to each other because of alternate interior angle. But now they have told these both are congruent. Therefore, these two lines are parallel because of alternate interior angles converse. Because of this, we tell the other way around. That is the answer. Now, what about the next one? Here, 3 and 11. Let's see where's 3 and 11. That's over here and over here. Now, look at these. They are corresponding angles. You can see this is the position down right. And which are the two lines that will become congruent? It is N and K. They prove that N and K are parallel. My apologies, these options are wrong. Why? Because it is L and M over here. That should be N and K. Well, because it's corresponding, that's correct. But it should have been N and K. That's the correct answer. That's how we solve that. Here, they have asked us to prove different lines. Let's see, this is 2 and 8. 2 and 8 means it's A and B. They are parallel to each other because of alternate interior angle. So it's A and B that are parallel. Alternate interior angles converse. And what about 3 and 11? It's corresponding angles, and they prove that L and M are congruent to each other. Now, why do we use the converse? Converse means actually we tell if they are parallel, then these angles are equal. But now we know the angles are equal, therefore these are parallel. We are basically conversing it. And now here we have 12 and 14. Where is 12 and 14? This is A and B here, but they are alternate and outside. Look, A and B, they're outside A and B. Therefore, alternate exterior angles. You can see here, that's the answer. But it's alternating. Now, these both will be parallel if these two lines, sorry, these both will be congruent if these both lines are parallel because of alternate exterior angles. But now we can tell these both are parallel because of alternate exterior angles, converse. Now here we have 1 and 15. Where is 1? Here it's 15. Let's see which is the one. See, if you know 1, this is fine. Here it's fine. They want the postulate. In fact, let's just look into the options. See, it is not possible. Look, there's no way it's possible to tell they are parallel. Yes, I can prove this and this, or down, and then I can relate it, but I can't directly tell it's parallel or anything from these two angles. So it should be not possible whether they are parallel or not. Now 3 and 5, yes, you can. It's alternate interior angles. We have done similar one. And L and M are parallel to each other. What about 3 and 10? 3 and 10 over here. Add them up. See, this is consecutive angles. They are equal to 180 because of consecutive angle interior angles. Whenever you have two continuous angles in the parallel lines, these two are parallel over here, N and K. Then when you add them up, it should be 180 degree. That's the consecutive interior angles, converse. In this question, we will make conjectures based on inductive reasoning. Now here they have asked us to make a conjecture. You can see the arrival times are 3 p.m., 12 p.m., 10 p.m., which would be the most probable next time which would be written. Now you can see the times are going backwards. 3, 12, 10. By how much? From 10 to 12, it's 2 hours, 2.5 hours. So it's going time prior. There is 2.5 hours, or time is going backwards by 2.5 hours. So it's either B or D. So let's do 2.5 hours from 10. It's going to be 9, 8, 7:30 a.m. So it should be option B here. That will be the correct answer. It's a very, very simple topic. Now, what about this one here? You can see this is the given pattern. First, it's at the top left, then left down, right down, and it should go up, right? Imagine you're spinning it. It's coming down, down, and now up. So it should be option A. That'll be top right. Now, which are the next terms here? 4, 8, 12, 16. It's, adding by 4. So it's going to be 24. That's the next term. What is the pattern? You're adding 4 to the previous terms. Now, what about this? 2, double 2, triple 2. Now it's 4 2s. That's next going to be 5 2s. 1, 2, 3, 4, 5. Keep on adding a digit 2, that is additional digits as 2. And here we have 1/2, 1/4, 1/8. So you're cutting things into half. You're multiplying everything by half. 1/2, 1/4, 1/8, 1/16 would be the next term. You just have to divide the denominator. That's 8 by 2. That'll be 1/16. So it's 1/2 of the previous terms. Now what about over here? 6, 11 by 2. What is 11 by 2 exactly? It's 5.5. Then this is 4.5. 4. 3.5, or we can write 3.5 as 7 by 2. So that's it. You can see 11, 9, 7 by 2 would be 3.5. So each term is 1/2 less than the previous one. You're subtracting half from the previous one. Here the arrival times are at 3 p.m., 12 p.m., 10 a.m. And we did this a while ago. It's 2 hours, 30 minutes prior to the previous one. It's 7:30 a.m. Now what about the humidity? 100%, 93%, 96, 86%. You can see there's a difference of 7. Subtract 7, it's going to be 79%. Each percentage is 7% less than the previous one. This pattern we did see, it's going to go down, right, and then now top right. So that will be the answer. What about this one here? You have 4 columns, 3 columns, 2 columns. Next will be just 1 column, up and down. This will be the thing. Each column has been decreased by 1. Before moving ahead, a quick reminder and a humble request. Please do share my channel and my videos with your friends and to whoever that can benefit from it. And I also kindly ask you if you can hit the subscribe button and like my videos, it would mean a lot. In this question, we will find angles using the properties of isosceles triangles. Here we have been told to find the measure of each angle. That's ACD. Let's see, where's ACD is over here. We have been told, let's only focus on the smaller triangle. We have been told this ADC is 92, almost right angle. These two sides are equal. That means these two angles must be equal. That's the properties of isosceles triangle. So now I know this is 92, this will be x, and this should be x. They are equal. Let us assume x plus, not assume, let's consider x plus x, these two angles, plus 92 must be equal to 180 degree, isn't it? Why? Because that's a triangle. Total angle is 180 degree. So this is going to be 2x plus, let me take it to the other side, is equal to 180 minus 92. That will be 90 minus 2, that is 88. 2x, x will be equal to 44 degrees. So that is the correct answer. What you can do is just use this equation in the calculator, or you can just look at this. See, it's 92, so these both are equal. If it's 90, 45, 45, but these are two more, so one less over here, 44. Anyway, whichever method is comfortable, just use that. Now, what about CAD? CAD, now literally we did the same thing. The x's both are same, it should be 44 itself. Now let's find more of these angles. CAD, we just now found out, was 44. ACD is 44 as well. This is 44. Now what about ACB? ACB. Now they want is this angle. Want us to find this angle. Now I know this side it's 44 and this is a linear pair, so it's 180 degree in total, right? 180 degree minus 44 degrees would give you the answer. It'll be 136 degrees over here. So ACB will be 136. If this is 136, what is ABC? That is ABC, this angle here. What is this angle? See, now these both are equal. So how much can these both angles be? See, this is 136. Out of 180, this much is 136. So 44 is remaining for both of these angles, and these must be same. Why? Because look at this. This base and this base, this leg and this leg are equal. So it's isosceles triangle. These both are equal. So you can do like this. X plus 136 degrees is equal to 180. And you can solve it up. We just found out this two angles will be 44. So each of it is 22 degrees basically. So 2x will be equal to 44. When you do 180 minus 136, x is equal to 22 degrees. So the answer is 22 here. That's the answer. We have a real world problem. A marble path as shown at the right is constructed out of several congruent isosceles triangles. You can see these are all isosceles triangles. So what is the important factor in this? These both angles, they're all equal. The base angles are equal. Okay. And all vertex angles measure to be 20 degrees. Now, which is the vertex angle? This one. That is 20 here, 20 degrees here, 20 degrees here. So that is known. What is the measure of angle 1? Now it's not very clear, but this is the angle 1. Assume this is the angle 1. See this part. Now how can you find is, we have to assume this is to be a straight line. Okay, if this is a straight line, then what happens? This much plus this angle will be equal to how much? 180 degrees. So that everything, when you add it up, is 180 degree. So we got one vertex. So this is 20 degrees given to us. Now, if in a triangle, this is 20 degrees and this is an isosceles, so this and this is equal, right? So what are these angles? So what we can do is consider them to be x and x, and let's measure 20 plus 2x, because 2x's are there, is equal to 180 degrees. So it'll be 2x equals 180 minus 20 is 160 degrees, or x is equal to 80 degrees. So now this is 80, this is 80. That's 20. Now I found this to be 80. So what is the total? It will be 180 will be equal to measure of angle 1 plus 80 plus 20. So this is going to be 100 degrees plus one angle, and this is 180. Just subtract both the sides by 100. 80 degrees is equal to the measure of angle 1. That is how we can find it out. So it's approximately 80 itself. Now it actually, is not very accurate enough, because that is how it is solved over here as well. But look here, it should be more clearer where exactly is angle 1 line. It looks more like 90 degrees. Now, in your exams, it'll be more clear, so not to worry, you can take it as proper angles. But now, with what we know, that's the vertex angle and this base, and then this measure of angle, we can consider it to be 80 degrees. In this question, you will solve for the corresponding parts of a congruent polygon. Here they have told triangle ABC is congruent to triangle FDE. What does this mean? Now it's very careful. Don't look at the figure at once. Over here you can, but this is very important. This means the first letter or the angles A and F are equal. B and D are equal. Where is B? This one and this one is equal. So what is Y degrees? B and D are equal. So Y is 48 degrees. But that is not what we need to find. We have to find X. And lastly, we have C and E that are equal. Now here they have told F is 2x minus Y. But we know what is Y. That's 48 degrees. What is A exactly? You know, this is 108. This is 48. So what's the remaining angle? You can do 180 minus it's 48 minus 108. So this will be 140, 56. So 180 minus 156, that will be 24 degrees. Now A is just 24 degrees, but that is equal to 2x minus y. So I'll solve it up in the equation. 2x minus y is 48 degrees. That is equal to 24. You can put this in the calculator and get it if you want. 2x will be equal to 24 plus 48. That is going to be 72. X will be equal to 36 degrees. So here the option is D. It should be 36 degrees. That's how we solve it. First, we need to find the relation. Okay, we know what is y. And then see what is this a. Then we can equate it with 2x minus y, which is 48. And then we can find the only variable x, which is unknown. What about this problem here? They have told in this figure ABC, that is this, with DEF. So A35 is equal to 2y minus 5. I don't need to do anything else. Why? Because I'm just wanting what y. So 65 is equal to 2y minus 5. Take 5 to the other side, it will be 70 because it will be 65 plus 5. That's 2y. Divide both the sides by 2, it will be 35 degrees. That is equal to y. So here 35 is the correct answer. That is option C. Let's solve the other problems quickly. We did this at the beginning. Do you remember we found out y and x? So this was 36. But what is the value of y? You don't need to solve anything. You have to just look over here. Y is 48 degrees. That would be the answer. And find the value of x. Now this is a polygon with 4 angles. This is a 4 sides. Basically A, B, C, D is congruent to P, Q, R, S. See, it's not aligned. It's upside down, but that's fine. We are looking at A, that is equal to P. So what is A value? We need to find x. So I'm just going to equate these both. 2x plus 4 is equal to 100. So it'll be 2x is equal to 96. That is 100 minus 4. X will be equal to 48. 48 times 2 is 96. So x value is 48 degrees. What about the same question for y? Now here, what is y exactly? It's dy, right? What is d? Sorry, it's dc or cd, you can take it as. Which is the congruent line over here? It's rs, not any other thing. Rs, where is rs? This is the line. So we can tell 3y minus 3, that is cd or dc, is equal to rs or sr. That is equal to 12. So it will be 3y is equal to 12 plus 3 is 15. Y is equal to both the sides by 3, that is 5. And here we go, y is equal to 5. So x was 48 from these two angles. But why we need to equate the sides? Because they are congruent. So angles and the sides are equal. And there we go. What about this one? We did find this. I hope you remember. We got 35, I believe, for x. Now the value of x, no, y was 35. No, we did not solve for x. Let me solve it up over here. Where is x? That is over here. 2x plus y, that is EF. What is the line called? So I know 2x plus y is equal to EF. But what is congruent with EF? BC. Where is BC? That is equal to 90.6. Now, in order to get to this, I need to know y. And we did solve y a while ago, but I'll do it again. Now, where is y? That is angle D. So angle D is congruent to angle A. So what is A? 65. So 2y minus phi is equal to 65 degrees. And let's solve it up. Here will be 2y is equal to 65 plus phi will be 70 degrees. Y equals 35 degrees. It's not over now. You need to substitute back it to 2x plus 35. In your exam, you might get this. It's not to solve for y, to solve for x, but if you solve y, that might be there in your four options. Don't select that. You need to continue further to find the x value as well. 90.6. So let's take this to the other side. It's going to be 55.6 2x is equal to, that's going to be 27.5 plus 3 is 27.8 is x. So the dimension of x, or the value of x, is 27.8. So dividing both the sides, you can just use a calculator over here and get the direct answer as well. So there we go. And the y we just now found out is 35. In this question, we will use right triangle congruence theorems. Here you can see there are few important theorems or the congruences which you need to remember. That is first one, leg, leg. What does that mean? When it's a right triangle, when you have two right triangles and they, if it's a right triangle, the opposite side is hypotenuse and the remaining one are two legs. If at all the two legs are equal to each other, this is one triangle, this is one more, but their legs are equal and it's a right triangle, you don't need to worry about any other sides or angle. You can just tell they are congruent, because that is the property of right triangle congruence, leg leg congruency. That's LL congruence. What about hypotenuse and angle? If you know hypotenuse, that will be the opposite side of right triangle, and one of the angle, it can be this angle or this angle, hypotenuse and at least one of the angles. See, it should be a leg angle. Why? Because hypotenuse, the opposite side is always 90 degree. One of the other angle, that's it. But now, what if I know the angle D here and I know angle C are congruent, but that is not aligned properly? See here, when you align them properly, it must be D and A. If it is C, then it must be F here. So that is very important. The corresponding, the corresponding paths itself must be congruent. So one hypotenuse and one angle. What about this leg and angle and leg and hypotenuse and leg? HL, hypotenuse and one of the leg, then they're congruent. That is also right triangle congruence property. And we had what? Leg and angle. So if at all you know one leg is congruent for sure, and then one angle is congruent for sure, then that is again those two triangles are congruent. So these are the properties. Let's look into the problems. You can see here they have told us to determine whether these two triangles are congruent or not. These two are right triangles, and if so, you should tell which is the property. Now, option A is no, not enough information, no, HA theorem, yes, HA theorem, and yes, LA theorem. Let's see about this. Ignore these options for a minute. Let's see what we know. This is a right angle triangle, right angle triangle. They're aligned properly. This is the upper angle. This and this is equal. Yes. This is hypotenuse equal. So we can see hypotenuse and that angle is equal. So yes, it's HA theorem that is congruent. That's it. And what about this one here? We know these both are triangles, right triangle, right angle, triangle. Now let me write these letters A, B, C. Let me write A, B, C. Now here it's very important to write the same way. A is an angle. Now imagine that's D here. Then next comes B, that is the hypotenuse length. So it will be DE over here. And the last angle, right angle triangle, is given at F. So C and F, yes, are right angle triangle. A and A, yes. Now what do we know? We know AB is hypotenuse, D is hypotenuse. But they didn't give us anything, so it's fine. This is properly aligned now, what is written. Now we know BC is equal. So BC is equal. Here, if BC is equal, then EF must be equal. Do we have even EF? No, we have F and D, that is a different side altogether. They are not corresponding sides at all. A and A, yes, this angle and this angle is equal. That's okay, but we don't have this side and this side. If it was BC and EF, then yes, I could say that is angle and leg, LA. Or if it was, say, for example, these two and these two legs, then it would be LL. If the hypotenuse and one angle was given, it's HA. This is not enough information at all, because these two are equal. Okay, but what about this and this? No idea, right? So we can't say these are equal, so it's not enough information here. Let's look at some more problems. You can see here, this is a rectangle, but they have a diagonal which cuts into two triangles. So there are two triangles which make into a rectangle here, and they have given us one leg, the opposite leg. Yeah, these two are fine. What about the hypotenuse? The hypotenuse is literally the same for both triangles, isn't it? This triangle and this triangle. So that is basically HL. HL, yes, H and L. Why? Because hypotenuse and leg. What about this one here? Yes, this is a leg and an angle. LA. LA theorem. And here there are two legs. Yes, absolutely. LL theorem. And what about this one? We did this. There is no information, because if we have BC, it should have been EF, but no, it's not. So there is no enough information to prove this. What about here? We have a hypotenuse and an angle, so it's H and A. HA, that is a hypotenuse and an angle. And here we have right angle and only one leg. See, there is no theorem that says only one leg is equal. We need something else other than the right angle triangle, right? Right angle point. So we can't say, there's no information here. So we just say there's no enough information. And that is the end of all the electronic part questions. I hope you have found these videos helpful. And if you can do a huge favor to me, that is by sharing these videos with your friends who also can benefit from it. All the advanced grade videos, EOTs, and lesson explanations are available. Please do share it for those who can benefit. And also, if you could subscribe to my channel or like these videos, it would mean a lot to me. Thank you very much for watching my videos. I wish you all the best for the exam.